Hello and welcome back to yet another Target JEE Advanced series videos brought to you by Byju's. In today's video, we are going to look at a mathematics chapter, a chapter from coordinate geometry, and a chapter that is of utmost importance for the JEE Advanced examination. This chapter is Introduction to Conic Sections and Parabolas. We're going to focus mainly on parabolas because parabolas is the single most important chapter of JEE. Now, why is this chapter so important? Very simple. Innumerable questions come from this chapter in every examination that you're going to face after your 12th standard. Be it the JEE main examination or the JEE advanced examination or any competitive examination that you're going to give, parabolas will inevitably seep in and they will attack you with a number of questions. If you take the case of the JEE main examination, in the past 6 or 7 years, every year, 1 or 2 questions have definitely come. Take the case of 2013. There were 2 questions from parabola. One assertion reasoning type of question, one straightforward multiple choice question. And both these questions had concepts of a circle and parabola intertwined. 2014, again, there was one question. This time, it was the intertwining of lines and parabolas. So was the case in 2015. In 2016, we saw the case wherein there was a circle and parabola question. 2017, again, there was a question which involved concepts of different conic sections, parabola being a part of it. Again, in 2018, we had 2 questions from parabola, and both these questions had concepts of circles along with it. And in 2019 too, in the different shifts, we saw questions from various conic sections, a lot of priority given to parabola. So if you see in the main examination, parabola plays a very important role, but parabola doesn't come on its own. Other conic sections and other concepts of coordinate geometry are also associated very strongly with parabola. Circle and parabola is one of the most interesting combinations, and a lot of exam questions will have circles and parabolas intertwined. Now let's talk about the all-important advanced examination. Well, when it comes to advanced examination, if you don't know parabolas, I'm slightly worried because every year in the advanced examination, 2 questions come from parabola at least. And if you don't know parabola, you're losing a lot of marks. Let's take the case of 2013. There was one passage type of questions, which means there were 2 questions from that passage. And then there was one match the following type of questions. And these questions had a lot of concepts of parabolas involved. There was application of tangents and normals of parabola. There was application of focal chord of a parabola in these questions. So 2013 advanced examination was very high on parabola. That was the case all through from 2014 until 2018. In 14, again, we had 2 questions. One question from common tangent. That was a single correct answer kind of question. And then there was one question which is a passage type of questions, which means there were 2 questions to follow. And this tested your understanding of the parametric form of parabola. Then think about 2015. Well, if you went into the examination hall without knowing parabolas in 2015, you lose marks for 3 questions because there were 3 questions from parabola this year. There were 2 integer type of questions and there was one multiple correct answer kind of question. The multiple correct answer kind of question involved concepts of both circles and parabolas and a little to do with tangents. The multiple correct answer kind of questions, one was based on the image of a parabola about a line and the other one had to do with tangents, normals, circles, a multi-concept questions which had a lot of focus on parabolas. So you are seeing the trend. Parabolas always test you immensely in the examination hall, and if you don't know this chapter, you will end up actually losing a lot of marks. 2016, one of those lucky years where people, if they did not know parabolas, could have still managed because only one question came, and this question was a multiple correct answer question, again involved concepts of both circles and parabolas and a little bit of tangents. 2017, wow, this was a year when parabolas found a lot of applications. Well, they actually compensated for not asking questions in 2016 by asking 4 questions in 2017. There was one multiple correct answer questions on tangents, and then there was a match the following type of questions which had 3 parts to it. So in a total of 4 questions from parabolas. Well, the match the following was not solely based on parabolas. There was ellipses and circles also involved. But again, you see parabolas found so many applications in this 2017 question. 2018 again, there were 2 questions. Again, a lot of conic sections were intertwined. There were circles and ellipses and parabolas all intertwined in a couple of multiple correct answer kind of questions. So you see how important parabolas is in the mains and advanced examinations. Inevitably, number of questions will come in the examination, and if you don't know this chapter, you will lose a lot of marks. And so it's important that you know the concepts of this chapter, and very quickly I'm going to talk about the important concepts of this chapter that will help you solve questions in the JEE examinations. So parabola is introduced for the first time in your 11th standard in coordinate geometry. Of course, you've seen parabolas before in quadratic equations, but not from a coordinate geometry perspective. So you begin by looking at the standard parabolas, which are there: y square equal to 4ax, x square equal to 4ay. And then you're introduced to terms. What is the vertex of a parabola, focus of a parabola, directrix of a parabola? Of course, you have to remember the definition of a parabola. That's where the focus and the directrix actually originate. Then we move on to looking at more properties such as the latus, rectum of a parabola. And then we look at shifted parabolas. We move from parabolas who have their vertex at the origin to parabolas which are shifted, whose vertices lie somewhere in the 4 quadrants or on the different axes. Then we look at interesting concepts. We look at tangents to a parabola, different ways in which tangents can be expressed. Then we look at what are the normals to a parabola. We look at focal chords of a parabola. All these are very interesting topics, and they're going to find a lot of applications in the questions that come from parabola. But there is one concept that is going to be massively important when it comes to questions from parabola, and that is going to be the parametric form of a parabola. How to represent a parabola in its parametric form. So this is the parametric form of a parabola. How do you express the equation of a tangent in the parametric form? How do you play with the focal chord when it comes to parametric form? What happens to the normals of a parabola when you look at it from a parametric form? All these are going to make a lot of impact in question solving. If you do not know the parametric form of a parabola, if you do not understand how to play with the parametric form of a parabola, you're going to suffer when you're going to solve questions from parabola. So make sure that you understand the parametric form of a parabola really well, because that's going to pay you a lot of dividend, because question solving will then become really easy. Any concept from parabola can be solved easily using the parametric form, and I'm going to show it to you in the questions that are going to follow. In most of these questions, I'm going to solve the question by making use of the very famous parametric form of a parabola. So these are the concepts that are there in the chapter. This chapter is very heavy on formulae, a lot of formulae to be remembered, a lot of relations to be remembered. And I do not expect anyone to by heart or mug these formulae, but solve a lot of questions, derive these formulae yourself, and make sure that these formulae are embedded in your system. And as soon as you see a question, you understand which formula to be solved and what is the end result that you're going to arrive at after application of that formula. So let's quickly jump on into solving questions, and let's do some very interesting questions from parabola. And these questions are going to give you a little bit of insight on the types of questions that appear from this chapter in the advanced examination. So here is your first question. So in this first question, we've been told that a tangent is drawn to the parabola y square minus 4x plus 4 equal to 0. So this is the parabola that has been given to us. And this tangent is drawn at a point P. Now the tangent drawn at P cuts the directrix at yet another point Q. Further, we've been told that there is a point R such that this point R externally divides QP in the ratio 1:2. The objective of this question is to find the locus of this point R. So how do you go about this question? First of all, let's try and visualize what they have given us in this question. So we have this parabola which is going to be y square minus 4x plus 4 equal to 0. But I don't like writing the parabola equation in this way because it doesn't give us a lot of information. So I'm going to rewrite the equation of the parabola in the form that we know, and I'm going to write it as y square equal to 4x minus 4 and further write it as 4 times x minus 1. So as soon as I write this, now I can visualize the parabola much better, because from this equation I can visualize each of the points. Where is the vertex? The vertex is going to be at 1, 0. Where is the focus? The focus is going to be at 2, 0, because this is 4 times x minus 1. A is 1 and x1 is 1. So the focus is going to be at 2, 0. So the equation of the directrix would have been x equal to minus a if we had the standard parabola y square equal to 4ax. But now we have the parabola y square equal to 4a times x minus x1. So the equation changes and it becomes x equal to minus a plus x1. So in this way we get x equal to 0 as the equation of the directrix. Now equation of the directrix is important for us in this question because we've been told that the tangent cuts the directrix at some point. So whenever we have a parabola question, it is always advisable to solve the question in its parametric form, because that makes the question really easy. So I'm going to consider the parameters of point P. So let's say that T is the parameter at point P, then the parametric form of the parabola for point P will be 1 plus t square, 2t. Okay, so if the parametric form of the parabola at P is 1 plus t square, 2t, then I can express the slope of the tangent at that point in terms of t. Well, the slope is going to be equal to 1 upon t. Even if you don't remember how to get the slope, you can on the spot differentiate this curve and arrive y square equal to 4 times x minus 1. You will get 2y dash equal to 4, and then y dash will turn out to be equal to 1 by t if you substitute the value of y equal to 2t. So the slope of the tangent is 1 by t, and I know the point P in terms of t, so I can write the equation of the tangent as y minus 2t equal to the slope, which is 1 upon t, times x minus the x coordinate in terms of t, which is going to be 1 plus t square. So this is going to be the equation of the tangent at point P in terms of the parameter t. Now they've told us that this tangent, which is a tangent at point P, cuts the directrix at a point Q. But we know the equation of the directrix. The equation of the directrix is a very easy one, x equal to 0. So in order to find out the y coordinate of the point Q, which is the point where the tangent cuts the directrix, all that I need to do is substitute this value of x equal to 0. As soon as I do that, I get y minus 2t to be equal to negative of 1 plus t square divided by t. Now I need to do a little bit of simplification, and if I do a little bit of simplification, I'll get the value of y to be equal to t minus 1 by t. So the coordinate of point Q is 0, t minus 1 by t. So now I have the coordinates of point P, I have the coordinates of point Q, and I know what point R does. Point R externally divides QP in the ratio 1:2. So I'm going to use the section formula, but the external division section formula, not the internal division section formula. And let's consider R to have the coordinates x, y. Using the external division of the section formula, I get the coordinates of x, y in terms of t in this particular way. I just use the section formula here, nothing else. Nothing very fancy there. So from there, if you simplify, you get the value of the x coordinate of point R to be equal to negative of 1 minus t square, and the y coordinate to be equal to negative of 2 over t. So now we need the locus in terms of x and y. So from the second equation, I can easily write t to be equal to negative 2 over y, and I will substitute that in this first equation. I'll get x equal to negative 1 minus 4 over y square. A little bit of manipulation here and there, and you will end up with the locus of point R as y square times x plus 1 plus 4 equal to 0. So this is the correct answer to this question. A slightly lengthy question, but you can't help in questions which come from coordinate geometry, especially questions from parabola. They tend to be slightly lengthy, not many shortcuts as such, and you need to remember a lot of formula as you saw in this question. But I'm sure that with a lot of practice, you can do this in really quick time. So I hope you had fun solving this question. So in this question, we've been given a circle x square plus y square equal to 5 and a parabola y equal to bx square. Further, it has been told that AB is a common chord to both this circle and the parabola. Okay. Now, to this parabola, tangents are drawn at points A and B. Now, what is AB? AB was the common chord. So, the endpoint of the common chord, at these points, we draw tangents to the parabola y equal to bx square. Now, these tangents intersect at a point T. What is special about the point T? The point T lies on the directrix of the parabola. The objective of this question is to find out the value of 1 upon B. A very interesting question. So let's try and solve this question and see for ourselves how we arrive at the solution. It's a very interesting question. First of all, we've been given the equation of the parabola, which is y equal to bx square. But I don't like writing the equation in this way, so I'm going to rewrite it in a way which I'm familiar with. So I'm going to write it as x square equal to y by b. Now let's compare it with the standard form, which is x square equal to 4ay. And from there, I get 4a equal to 1 upon b, or a equal to 1 by 4b. Right? So, what is the equation of the directrix of this particular parabola? Well, the equation would have been y equal to negative a, and a is 1 upon 4b. So, the equation of the directrix of this parabola is nothing but y equal to negative 1 upon 4b. So, this is the directrix of this particular parabola, y equal to negative 1 over 4b. Fine, let's keep this aside for some time because we need this information later on because the tangents meet at a point which lies on the directrix. So we're going to use it there. So now I have these 2 points A and B, which are the end points of the chord, which is common to both the circle and the parabola. So A and B both lie on the parabola. Now I'm going to write coordinates of A in terms of the parametric form of a parabola. So remember, whenever we deal with a parabola question, we are going to make use of the parametric form because that makes life really easy. So A will have the coordinates 2at, at square if t is the parameter of the parabola at point A. I know what the value of A is, or what is A? A is 1 upon 4b. So if I substitute the value of small a as 1 upon 4b, then I will get the coordinates of capital A as t divided by 2b, t square divided by 4b. Okay, so now this point also lies on the circle x square plus y square equal to 5. So what is the beauty of this question is the fact that if A has coordinates t upon 2b, t square upon 4b, remember this is an upward facing parabola, then B will have coordinates negative t upon 2b, t square upon 4b. Even if the parabola was a downward facing parabola, this would have been the same case. So t will have a plus or minus in the coordinates of the x coordinate, but the y coordinate is going to stay the same. That's going to be t square divided by 4b. The reason why this is true is because the parabola is not a right or left parabola. The parabola is an up or down parabola, so the y coordinates of that point will remain the same. The x coordinate will just swap in sign. The reason for this, as I've already mentioned, the point lies both on the circle and the parabola. So I am not going to solve the equation of a circle and then arrive at the other point, the common points. That's not needed in this case. So I got what points A and B are. So these are the coordinates of point A and B. Now we have to draw tangents at points A and B. Okay, so what is the slope of the tangent at point A and B? For that matter, let's consider the slope of the tangent at any random point to this parabola, which is going to be y equal to bx square. I'm going to write it in this way because then I can actually find out what is the slope in a very easy way. Just by differentiating, I get y dash equal to 2bx. Okay, so y dash is 2bx, so the slope of the tangent at any point is going to be 2b times the x coordinate of that point. So at point A, the slope of the tangent is going to be equal to y dash equal to 2b into what is the x coordinate there? The x coordinate is t divided by 2b. So the slope at that point is going to be equal to t. The slope at the other point, which is b, so this is y dash at A, y dash at B, if you compute, will be equal to negative t. So I get these two as the slopes of the two tangents at point A and point B. Now I can easily write down the equation of the tangents at A and B. Very easy, because I know the coordinates of A and B in terms of the parameter. I also know the slope in terms of the parameter. So in terms of that parameter t, I can write down the equations of the tangents at points A and B. These are the equations of the tangents. Now these tangents intersect at a point, so which means you have to solve these two equations simultaneously. And if I do that, I'm going to subtract equation 1 from equation 2 or 2 from 1. If I do that subtraction, I will end up with x equal to 0. Okay, so I will end up with x equal to 0. Then I substitute the value of x equal to 0 in this equation, and what do I get? Y minus t square upon 4b equal to a negative t square upon 2b. Take the t square upon 4b to the other side, and I will immediately get y equal to negative t square upon 4b. Very interesting, isn't it? I actually got the x coordinate to be equal to 0, and then I got y equal to negative t square upon 4b. What has been specifically told about this point of intersection of the two tangents? It lies on the directrix. Remember the equation of the directrix? Y equal to negative 1 over 4b. So I have to equate the y coordinate of the point of intersection to negative 1 upon 4b. So I say minus t square upon 4b is negative 1 upon 4b. The 4b's will cancel, the negative ones cancel. I get t square is 1, or t equal to plus or minus 1. So if you put the value of t equal to plus 1, you get the coordinates of A. You put the value of t equal to minus 1, you actually get the coordinates of point B. That is how beautiful this question is. Everything is so closely interrelated. So points A and B in terms of B, the small letter b, are going to be plus or minus 1 upon 2b, comma 1 upon 4b. Remember, the y coordinate is going to remain the same, but the x coordinate will swap in sign when we move from A to B. So these are the coordinates of point A and B. Now we have to find out the value of small b. What other information can we make use of? Well, we can make use of the fact that points A and B both lie on the circle x square plus y square equal to 5. Right? So I'm going to substitute the value of x. I don't mind using negative 1 over 2b or positive 1 over 2b because we have an x square. So upon substituting that, I get 1 over 4b square plus 1 over 16b square equal to 5. Take a common denominator of 16b square and I get 5 over 16b square equal to 5. The 5's cancel, and what am I left with? I am left with b equal to plus or minus 1 over 4. Now there is one more bit of information that you can actually grab from the value of b. If b was 1 over 4, you had the upward facing parabola. If b was negative 1 over 4, you had the downward facing parabola. So in this question, we've taken care of each and every possibility. Upward parabola, a and b swapping positions. Downward parabola, again a and b swapping positions. That's what is happening with the b being plus or minus 1 by 4 and t being plus or minus 1. A very beautifully designed question. I've got the value of b to be equal to plus or minus 1 by 4. The objective of this question was to find out the value of 1 over b. So 1 over b is nothing but plus or minus 4. So whichever option says the value of 1 over b to be equal to plus or minus 4 are the correct answers to this question. A very interesting question. This is a beautifully designed question. I hope you had a lot of fun solving this question. This is yet another interesting question. We've been told that AB is a normal chord to the parabola y square minus 12x equal to 0. Notice the word normal chord. We're going to make use of that extensively in this question. Further, AB subtends a right angle at the vertex of this parabola. And finally, we've been told that the point of intersection of the normals drawn at point A and B to the parabola is P, Q. And the objective is to find out the value of P square divided by Q square. Very interesting question, and it's going to be a little long, but let's do it systematically because there's no shortcut available to do this question. Let's do it in a very systematic way. First thing, y square minus 12x equal to 0. I don't like any parabola's equation written in this way. I'm going to write it in a way I recognize. Y square equal to 12x. This is of the form y square equal to 4ax and my a is nothing but 3. Okay. Now, A and B are 2 points on this parabola because AB is a chord. Even though a normal chord, we're now going to focus on the fact that it's a chord. So A and B are points on the parabola. So I'm going to write the coordinates of A and B in which form? No points for guessing here because I'm going to make use of the parametric form. So my A is going to have coordinates 3t1 square, 6t1. And B will have another parameter t2. That's going to be 3t2 square, 6t2. Okay, these are the coordinates of A and B in terms of their respective parameters t1 and t2. Now, what is the vertex of this parabola? The parabola is y square equal to 12x, which means that the vertex of the parabola is 0, 0, the origin itself. Correct? So O is the origin, which is also the vertex of this parabola. The information given in the question is that from AB, the angle subtended at the vertex is 90 degrees. This means if I connect O to A and O to B, OA will be perpendicular to OB. This means that the slope of OA multiplied by the slope of OB would be -1. Again, a very simple concept. What is the slope of OA? Very simple because we know the coordinates of A. O is anyway 0, 0. So the slope of that will be 6t1 divided by 3t1 square. And the slope of OB will be a similar way, 6t2 divided by 3t2 square. And upon multiplying this, we should get -1. So all the t1s, t2s are all cancelled out. And eventually you get t1, t2 to be equal to -4. This is going to be one of the equations we are going to make use of in order to arrive at the values of t1 and t2. The next piece of information that we are going to use in order to get the second equation to solve for t1 and t2 would be this underlined thing that I am shown here. AB is a normal chord. So what is a normal chord? A normal chord is actually a chord which is normal to the parabola at one of the points and it intersects the parabola at the other point. So if AB is a normal chord, there are two possibilities, isn't it? It can be normal to the parabola at point A and intersects the parabola at point B, or the other way around, which is going to be it intersects the parabola at point A and is normal at point B. We'll consider both the cases for completion in order to solve this question in a complete way. In the JEE examination, you can just consider one case and arrive at the solution in case if it's a single correct answer kind of question. So I'm going to consider that it is actually a normal at point A and intersects at point B first. Then I will have this equation which is t2 equal to -t1 minus 2 over t1. That's going to be the relation between t1 and t2 because it's normal at point A and intersects at point B. Let's try and solve this. What do I get? I get t1, t2 to be equal to -t1 square minus 2, correct? And t1, t2 is -4. So I have a minus everywhere. So I will actually get t1 square to be equal to 2, from which I get the value of t1 to be equal to plus or minus square root of 2. If t1 is plus or minus square root of 2, from this equation I get t2 to be equal to minus or plus 2 root 2. It's very important. If t1 is plus or minus, t2 will be minus or plus because their product is a negative number. Make sure you don't miss this fact. So we've been further told that the two normals drawn at point A and point B, they intersect. AB is already a normal to the parabola. So if you draw another normal at point B, where will they intersect? They will intersect at point B itself, right? Because AB is normal to the parabola at point A. So B is going to be the point of intersection of the two normals drawn at point A and B. So this means that the coordinates of point B was nothing but 3t2 square, 6t2. So just substitute the value of t2 there and I will get the coordinates of point B, which is nothing but the point of intersection of the two normals as 24, minus plus 12 root 2. we have to find out the value of p square upon q square. This is p, this is q. So p square upon q square is going to be 24 times 24 divided by 12 times 12 times 2, because root 2 square is 2. So this is going to be simplified and I will get the value of p square upon q square to be equal to 2. Immediately mark 2 if one of the options given is 2, and you can actually stop here if you're not interested in moving further. But I am interested in showing you the complete solution, so I will look at the other case wherein we consider the case where AB is a normal chord, with A being a point of intersection of the chord with the parabola and B being the point where the chord is normal to the parabola. Then the equation that I get will be slightly different. T1 equal to negative T2 minus 2 over T2. The simplification of this is going to be very similar, and I get T2 to be equal to plus minus root 2 this time, and that would imply T1 equal to minus plus root 2. If you look at this, T1 and T2 have just swapped their values. Now, what is the point of intersection of the normals drawn at point A and B? Well, AB is normal to the parabola at B. So if you draw a normal to the parabola at point A, AB and that normal will definitely intersect at point A. So the point of intersection of the two normals is going to be point A. Now, what are the coordinates of A? The coordinates of A are 3t1 square, 6t1, and the value of t1 is exactly like what it was the case of t2 in the previous case. So I'm going to get the same coordinates with 24, negative positive 12 root 2. So p square by q square is going to be 2 even in this case. So this was done just for the sake of completion. So in this question, doing only one part was more than sufficient. Again, a lengthy question, lots of concepts involved, lots of formulae to be remembered, but that's how parabola questions are going to be. Very beautiful question with a lot of concepts and pretty long. Make sure you practice many such questions and you're ready for the examination. I hope you had fun solving this question. Now in this question, we have a parabola y square equal to 4ax. Now there are two distinct chords of this parabola, and both of them pass through the point a, 2a. Now a, 2a actually lies on the parabola y square equal to 4ax. So these two distinct chords start from a, 2a. Okay, now we've been further told that these two chords have been bisected by the straight line x minus y plus 1 equal to 0. The last piece of information is that a is actually greater than 0. So the objective of this question is to find out which of the given options represents a possible length of the latus rectum of this particular parabola. An interesting question. I'm going to visualize this question for you. So I have y square equal to 4ax with a being positive. So this is going to be my parabola. Now I have a point a, 2a. This is a point which lies on the parabola. From there I have two chords coming out. So if I say this point a, 2a is point P, and the two chords are PA and PB, now I'm going to write down the coordinates of A and B in terms of parameters T1 and T2. Okay, so in terms of parameters T1 and T2, it's going to be a T1 square, 2a T1 for A, and for B it will be a T2 square, 2a T2. So now I know the coordinates of P, A and B. What has been further told? Now there is this straight line which is x minus y plus 1 equal to 0. So that's the straight line there. That straight line bisects both the chords, which means that the midpoints of both these chords lie on that straight line. So let's find out the coordinates of the midpoints of PA and PB. So these are the coordinates of the midpoints of PA and PB. Pretty straightforward. Everything is going to be in terms of A's and T1s and T2s. I'm not going to change anything. So it's a very simple application of midpoint formula. Now, the midpoints lie on that line x minus y plus 1 equal to 0. So substitute the value of x, y for the midpoint of PA and PB in the equation, and you get two equations. I've done a little bit of simplification. All that I've done is taken a common denominator of 2 and done the simplification. I get these two equations. Now notice these two equations, a T1 square minus 2a T1 plus 2 minus a equal to 0. That's the equation for T1. Then for T2, I have a T2 square minus 2a T2 plus 2 minus a equal to 0. So using the midpoint of PA and PB, I got these two equations, and these two equations look very identical, right? So if I replace T1 and T2 and merge these equations with a common variable T, I get at square minus 2at plus 2 minus a equal to 0. So now I have a quadratic in T, and I am very certain that this quadratic has two distinct solutions. Why? Because T1 and T2 are distinct because A and B are distinct points, correct? So I have a quadratic equation with two distinct solutions. What does that mean? That means that the discriminant is going to be greater than 0, correct? So the discriminant is going to be greater than 0. So I have 4a square minus 4a times 2 minus a equal to is greater than 0. And what do I know about A? I know A is a positive quantity. They've given that in the question. So I can actually divide throughout by 4A without changing the inequality because A is greater than 0. So what will I get? I will get A minus 2 minus A to be greater than 0. And if I simplify this, I get 2A minus 2 greater than 0 or A greater than 1. I was given A greater than 0, but I found out A is greater than 1. What is the length of the latus rectum of a parabola? Well, the length of the latus rectum is going to be 4 times A, and in case A is negative, you have to take a modulus. In this case, we know A is positive, so it's just 4 times A. So what is A? The relation we've just found out is A is greater than 1. This means 4A is going to be greater than 4. Look at the options. There's only one number which is greater than 4, and that is 5. So among the options that is given, the correct answer is going to be one of the possible lengths of the latus rectum is equal to 5. That's a shortcut way of arriving at the solution. Just find out the relation for A and think what is the possible answer, and this question is as good as solved. This was a slightly shorter question, and you should be very glad if such a question appears in the examination, because generally parabola questions tend to be really long. I hope you had fun solving this question, and we'll solve a few more questions before we close this video. So in this question, we've been given a parabola. The parabola is y square minus 2y minus 4x plus 5 equal to 0. Look at the form of the equation. This is not an equation we recognize, so we know what is the first task to be done. Rewrite the equation in a form we understand. What else has been told? One particular focal chord of this parabola has the x-intercept as 11 by 4. Now the objective of this question is to find the length of that focal chord. So let's get into business. First of all, let's rewrite this equation in a form that we recognize. So you see y square minus 2y, if I have a 1 there, then it will become y minus 1 the whole square, isn't it? So I can rewrite this as y square minus 2y plus 1. I'm going to keep all of that on the left hand side and take the remaining onto the right hand side. The minus 4x becomes a plus 4x. Now from the plus 5, I've borrowed 1, which means I'm left with 4 on the left hand side, which becomes a minus 4 when it comes to the right hand side. Very trivial. So the equation of the parabola is nothing but y minus 1 the whole square is 4 times x minus 1. Now this is a shifted parabola whose vertex is at 1, 1. Where is the focus of this parabola? The focus of this parabola is nothing but 2, 1. A equal to 1 in this case. H and K are 1 and 1. So A, H, K, all of them are 1. The focus is at H plus A, K. So that's going to be 2, 1. So I know the focus. The focus is 2, 1. And that focal chord, which is of interest, has an x-intercept of 11 by 4. This means that focal chord is going to pass through 11 by 4, 0. So now that focal chord is going to pass through the focus as well as the point 11 by 4, 0. Very easily I can write down what is the equation of that particular focal chord. It's going to be, I'm going to use a 2-point form. So it's going to be nothing but y minus 0 divided by x minus 11 by 4. That is equal to y2 minus y1. So y2 is going to be 1. 1 minus 0 is going to be a 1 there, divided by 2 minus 11 by 4. I'll do a little bit of simplification, and what will I get? Here I will get y by 4x minus 11 equal to 1 by negative 3. Okay, so upon simplifying, this will give me the equation 4x plus 3y equal to 11. So this is the equation of that focal chord of interest. Now you might be wondering, why did I write down the equation of the focal chord? Well, as soon as you see the focal chord, the drill tells you to write the endpoints in terms of its parameters, and then they use the relations, which is t1, t2 is minus 1, and also we know the slope of the focal chord is 2 divided by t1 plus t2. But that's going to be a lengthier method for this particular question. So I'm going to solve this question this way, which is an easier approach to arrive at the solution. Now I am going to consider a point on the parabola, one of the endpoints of the parabola through which this focal chord passes, as 1 plus t square comma 1 plus 2t. H and k are 1, remember. So the parametric form of this parabola is 1 plus t square comma 1 plus 2t. This is one of the endpoints of the focal chord, a point which lies on the parabola. I just have to substitute this in the equation of that focal chord, and I will get the values of t. So let me substitute that. So I get 4 plus 4t square plus 3 plus 6t minus 11 equal to 0. Now this is a quadratic equation. Simplifying this quadratic equation gives me 4t square plus 6t minus 4 equal to 0. Divide throughout by 2, and then if you factorize, you will end up with 2t minus 1 multiplied by t plus 2 equal to 0. Very easily you can get both the parameters of the endpoints of this focal chord. One t will be equal to half, the other t will be equal to negative 2. So t equal to negative 2 and t equal to half are the parameters corresponding to the two endpoints of the focal chord. If you use that other method, t1, t2 is minus 1 and 1 by t1, 2 by t1 plus t2 as the slope of the focal chord, well, that is much more tedious than this. That is why I use this method. Now, what do we have to find out? We have to find out the length of the focal chord. So we need the distance between the two endpoints of the focal chord. So what are the endpoints of the focal chord? Well, the endpoints of the focal chord will be 1 plus t1 square comma 1 plus 2 t1 if t1 is one of the values of t, and the other endpoint will be 1 plus t2 square comma 1 plus 2 t2 where t1 and t2 are minus 2 and half respectively. Now I don't have to find out the exact endpoints, because in order to find the distance between these 2 points, I'll have to use the distance formula, where I subtract the two x components and the y components and then take a square and square root. But then when I'm subtracting the x components and the y components, you see the ones will cancel out. So I don't actually need the exact coordinates, because the length of the focal chord is going to be under root of t2 square minus t1 square the whole square plus 2t2 minus 2t1 the whole square. That's all. So once I find out what is t1 and t2, I plug it into this formula and I will get the answer. Well, so now let's try and find out what is this t2 square. I will consider 1 of minus 2 and half as t1 and t2 respectively. So I get 4 minus 1 by 4 the whole square plus 2t2 will be then minus 4 minus of 1 the whole square. So upon simplifying this, what do I get? Upon simplifying this, I am going to get 15 by 4 the whole square, which will turn out to be 225 by 16 plus 5 square or minus 5 square, which is 25. I'm going to take a 25 common out. 25, the under root of that is 5, and then under root of 25 9s are 225, so I get a 9 by 16 plus 1. Now 9, 16, when you add 9 and 16, you get 25. It's a very famous Pythagoras triplet. So we are going to make use of that to simplify this. So the answer turns out to be 5 times under root of 25 by 16, which is 5 into 5 by 4. That's nothing but 25 by 4. So the length of the focal chord is nothing but 25 by 4. Well, there's another method of solving this question, which is using T1 T2 relation. But as I've told you, this is an easier trick of solving this question. Also remember, we never found out the exact coordinates of the endpoints of the focal chord. We use distance formula directly. See, all these are small tricks of the trade trade which will help you solve a question by saving, let's say, 10 seconds, 20 seconds. But these 10 and 20 seconds are invaluable when it comes to the JEE Advanced examination. So this was a slightly tricky question, but yeah, very easy to solve it once you know the tricks of the trade. Now here is the last question, and pay attention to this question because there's a lot of information given in this question. First of all, a parabola, y square minus 8x minus 16 equal to 0. Then a straight line, x minus y by root 3 equal to c. And this straight line passes through the focus of that parabola. Further, this straight line intersects the parabola at two different points, P and Q. That's not the end of it. It's been further told that the perpendicular bisector of PQ intersects the x-axis at some point A. A lot of information, isn't it? A parabola, a straight line which passes through the focus of the parabola. That straight line intersects the parabola at 2 points P and Q. Then we have a perpendicular bisector of PQ which intersects the x-axis at A. The objective is to find out the distance between point A and the focus of the parabola. That is AF if F is called the focus of the parabola. First of all, you know what is the drill. I don't like the equation the way it is given, so I'm going to change it. That's the first thing I do. Y square minus 8x minus 16 equal to 0 is going to be rewritten as y square equal to 8 times x plus 2. Now this is going to give me what is the value of a. Small a is going to be equal to 2. And the focus of this parabola, f, where is it that going to be? That's going to be at a plus x1, and x1 is minus 2 in this case. A is 2, so the focus is going to be 0, 0. Beautiful. The focus is at the origin. So I just need to find out the coordinates of point A, and then life is going to be really easy because distance formula from the origin is a very easy one. So yeah, let's just try and find out what are the coordinates of A. That's going to be a little bit of a trick. What has been told? X minus y by root 3 equal to 0 passes through the focus. Where is the focus? At 0, 0. So that's a straight line which passes through the origin, and a straight line which passes through the origin has the constant equal to 0. We get the value of c equal to 0, which means my straight line is nothing but x minus y root 3 is 0. Again, I don't like a straight line in this way, so I'm going to rewrite that as root 3x equal to y. That's the straight line that I have. Again, the next piece of information. This straight line intersects the parabola at two different points. Let's try and find out the coordinates of those 2 points. So I have root 3x equal to y. So I'm going to substitute the value of y equal to root 3x in the equation of the parabola, and I get 3x square equal to 8x plus 16. Or I get 3x square minus 8x minus 16 equal to 0. If you factorize this, you will end up with x minus 4 into 3x plus 4 equal to 0, or x equal to 4 and x equal to negative 4 over 3. We've got 2 points because the straight line intersects the parabola at 2 different points. So if x is negative 4 over 3, then y would be negative 4 over 3 multiplied by root 3, which will turn out to be negative 4 over root 3. So the 2 points are 4, 4 root 3 and negative 4 by 3, negative 4 by root 3. So these are the 2 points at which that straight line intersects the parabola. Next piece of information. So the perpendicular bisector of PQ, so if this is P and if this is Q, then the perpendicular bisector of PQ passes through a point A. So perpendicular bisector is going to pass through the midpoint of PQ. So let's find out the midpoint of PQ. The midpoint of PQ is going to be nothing but 4 by 3, 4 divided by root 3. We're just going to use the midpoint formula. So this is going to be the midpoint of PQ. Now, what is going to be the equation of the perpendicular bisector of PQ? Well, I know the slope of PQ. What is the slope of PQ? Well, PQ has the equation root 3x equal to y, which means the slope is root 3. the perpendicular bisector will have a slope of -1 over root 3. So the slope of the perpendicular bisector is -1 over root 3. I know the point through which it passes. I can easily write the equation of the perpendicular bisector. Y minus 4 divided by root 3 equal to -1 over root 3 into x minus 4 by 3. Now this perpendicular bisector intersects the x-axis at point A, which means that the y-coordinate of that point is going to be equal to 0. So I'm going to substitute the value of y equal to 0 here. So if I substitute the value of y equal to 0, I get -4 over root 3 as -1 over root 3 x minus 4 by 3. I can cancel out the root 3's. I can also cancel out the minus sign from there, and I'll be left with the 4 equal to x minus 4 by 3, which upon solving I get x equal to 4 plus 4 by 3, which is nothing but 16 by 3. So the coordinates of point A is 16 by 3, 0, and the coordinates of the focus is 0, 0. So the distance of the point A from the focus is going to be simply equal to 16 divided by 3. A very interesting question, lots of information. Take one information at a time and solve for that information and then move on to the next pieces of information. This is how you solve parabola questions. Well, as I have mentioned, parabola is not an easy chapter. There are n number of concepts in this chapter, and most of these concepts are pretty important from the JEE examination point of view. The most important thing in parabola, however, is the parametric form of a parabola. Never forget the parametric form and try to always solve questions using the parametric form of a parabola. Questions tend to be lengthy, but systematic solution will definitely make sure that you hit the jackpot and you get the question right. A parabola is a lot of fun to play around with, and I hope you solve more and more questions and gain enough practice to be confident with questions that come from parabola, and you will have a lot of fun solving these questions during your practice as well as in the examination. I hope you had fun watching this video and solving questions along with me. I will see you very soon with a few more interesting chapters and interesting questions that will help you prepare better for JEE. Stay tuned with Byju's, and we will be back very, very soon.
For more videos and live lectures on the JEE, click on the subscribe button now.